Chapter 3 The Experimentalists Part 1 How do microbes work? Do they eat, breathe, go to the bathroom? Can they get sick? What do microbes do for a living? Do they hunt, graze? Do they make nests or burrows or hives? And where do microbes come from? How do they keep showing up in places that didn't have microbes before? There was no easy way to answer these questions. For one thing, it was still difficult to see clearly what the microbes were doing. Ewan-Hicks microscopes were hard to use and had very tiny windows. Two-lens microscopes gave broad, clear images, but only at low power. If you tried to make a two-lens microscope too powerful, the image became washed out and blurry. So microscopists could only watch these creatures in a very limited way, like a wildlife photographer hiding in a tree and observing wildlife from afar. But no matter how clear the view through the microscope had been, it wouldn't have been enough. We would never have learned all we know about normal animals by watching them from a distance. We learn most of what we know from millennia of hunting them, feeding them, repelling them, and domesticating them for pets and livestock, as well as studying them deliberately in laboratories. Now we needed to do the same with Ewan-Hicks animalcules. To discover the habits and lifestyles of the microbes, and to learn whether they have any significance for human beings, passive observation through the microscope was not enough. The next step in the journey towards understanding microbes was to find ways to cage them, to learn how to raise them, to poke them and prod them in a test tube, and to see what happens if you try different things. Learning how the microcosm worked required experiments. During the same years that the first generation of microscopists was carefully describing and documenting the new world inside the microscope, another intellectual descendant of Galileo branched out in a different direction. Francesco Redi was another Italian, a contemporary of Malpighi, both of them living about a generation after Galileo. Galileo's ideas about putting the claims of authority to the test had inspired hostility from authority, but also courage and curiosity in a handful of the next generation. Redi was one of these. Redi specialized in medicine and biology, and he decided to start questioning established biological facts and putting them to the test. Francesco Redi was biology's first mythbuster. Where do microbes come from? Redi started to build his reputation in the early 1660s by clearing up some confusions about poisonous snakes, their bites, and some alleged antidotes. Redi's contemporary Athanasius Kircher had been claiming that one could draw the harmful substances out of a snakebite victim simply by placing special stones against the victim's skin. These snake stones had been brought back from the Far East by missionaries, where they had allegedly been extracted from the heads of snakes, and they were supposed to work like magical poison magnets. Redi showed that they didn't work. But a few years later, in Redi's magnum opus, he took a stand in an epic philosophical debate over the origins of life. Where do living organisms come from? The origin of new people is obvious. Livestock, too. One could make a list of trees and flowers and vegetables that obviously grew from seeds or nuts that were produced by an earlier plant. In all of these cases, living things come from prior living things, and some earlier living thing is always of the same kind. Humans have babies, rabbits give birth to rabbits, oak trees come from acorns produced by oak trees. Whenever a new life appears, there's always a parent of the same kind that created it. But maybe that's only true for large, sophisticated organisms. What about swarms of smaller, cruder vermin? What about maggots, grubs, slugs, worms, ants, wasps, and all other manner of squirmy, wriggly, creepy-crawly things? And what about algae? What about mold? Many of these things did not come from seeds or parents, at least not in the way we can see. Many of them seem to condense spontaneously anywhere the conditions are right, out of any murky matter that can incubate them. On one hand, it seems nice and tidy to just assume that everything is generated in a similar way. Living things might be born, hatch from eggs, or sprout from seeds, but they always come ultimately from a previous organism of the same kind. On the other hand, any devoted observer of nature could make a list of cases to the contrary. Sometimes one finds little wormy things in a place that no wormy things entered, such as maggots appearing from nowhere in a pile of dung. Sometimes a wasp will emerge from a lump or gall that grew from the side of a tree. Algae and slime grow in containers that once held nothing but pure water. Wherever the ingredients come together, living things are cooked up in nature's kitchen. Wherever life is possible, life is born. At least one later philosopher, Georges Buffon, tried to theorize about a living force that could flow through matter and assemble the elements of life into simple living things. Maybe that's where George Lucas got the idea. But worst of all, the assumption that all life comes from previous life doesn't really solve the problem. To say that living things always come from parents begs the question, where did the parents come from? It leaves you with an infinite regress. As the decades and centuries went on and the tide of Enlightenment science rose against the bulwark of religious authority, the question of the origin of life would also provide an additional battlefield for religious debate. The idea that living things always come from similar ancestors fits very nicely with the orderly religious idea of a single moment of creation. The idea that life could be cooked up here, there, anywhere seemed like the natural, messy, godless explanation. So, which is it? Can living things arise anywhere, naturally and spontaneously, wherever conditions are right? Or must every life form have parents, even swarms and slimes of the simplest and crudest kind? The only way to know for sure was through thorough investigation. Athanasius Kircher came down on the side of spontaneous generation. He had somehow managed to obtain a microscope, possibly from the nearby Linnaean Academy, but nobody really knows, and he claimed to have found worms everywhere he looked. Based on these observations, he then told stories about an invisible universal seed that was spread throughout nature and that sprouted into worms everywhere it found dung or diseased flesh or any kind of decaying matter. These worms could then give rise to higher and higher life forms. Kircher even gave recipes for creating things like bees, flies, and scorpions, but it's possible that he never even tried the recipes himself. Redi later showed that they didn't work any better than the snake stones. One of the places Kircher found worms was the blood of plague victims, and he wrote that, quote, plague in general is a living thing, unquote. For this, I have seen him credited at least once as the first person to connect disease with microscopic germs, but all Kircher had to offer were vague anecdotal reports of worms and speculation about universal seed. It is possible that the worms he saw in the blood of plague victims was nothing more than tiny clumps of clotted blood, and his recommendation for avoiding the plague wasn't any more useful than the snake stones. He suggested wearing an amulet over your heart made from the flesh of a toad. Oddly, however, I do wonder if one of his worms was really what we would now call a worm. He claimed to have seen worms in vinegar, and I have to wonder if he discovered or rediscovered the nematode worms we call vinegar eels. If he had documented his procedure more carefully and provided detailed descriptions of the worms, we might know. Francesco Redi came down on the other side of the debate. He believed that, in at least some cases, what seemed to be spontaneous generation really wasn't, and instead of simply asserting his belief, he tested it. The first controlled experiment. Are worms generated spontaneously in putrefying meat? Reddy decided to place some meat in a box where he could watch it carefully and control what happened to it, and simply observe what happened. Sure enough, worms appeared in the meat. But then they disappeared, and Reddy wasn't sure where they had gone. So he tried again, and this time he closed the box after the worms appeared so they couldn't escape. The trapped worms searched for a place to settle down, and then they turned into eggs, or at least something that looked like eggs. Small, firm containers of some kind, like those made by silkworms or by the mealworms you feed your pet lizard. Reddy wanted to observe the eggs carefully, separately, so he moved them to a glass jar and waited to see what came out, if anything. The eggs did in fact hatch into flies. By carefully controlling the circumstances of his observation, Reddy discovered that the worms were actually a different form of fly. Flies can transform themselves from one shape to another, just like butterflies and silkworms. As we would now say, the worm or maggot is the larva of the fly, and it goes through metamorphosis to become the adult fly. Redi repeated the test with many different kinds of meat, more than 17 different kinds by my count, including a variety of mammals, birds, and fish. I have no idea how he obtained tiger meat. Apparently, different kinds of flies prefer different kinds of meat, but in every case, Redi always observed the same sequence. Worm goes to egg, goes to fly, or what we now say more formally, larva goes to pupa, goes to adult insect. Redi had discovered that certain worms transform into flies, but he still hadn't answered the original question: where do the worms come from? Redi had noticed that flies were always hovering and buzzing around the meat, usually the same kind of fly that later hatched from the worms. Could the worms come from the flies somehow? Was there a full circle, a life cycle that began and ended with the fly? Redi wrote, quote, "Having considered things, I began to believe that all the worms found in the meat were derived directly from the dropping of the flies, and not from the putrefaction of the meat." Less thorough thinkers may have been content with an assumption, but not Redi. As Redi said, quote, "Belief would be vain without the confirmation of experiment." Unquote. But how could he create a truly convincing experiment and not just an anecdotal observation? Suppose you place fresh meat in a container on your patio and you cover it so maggots can't get in, and you watch what happens, and no maggots appear. Would that really prove that they can never appear spontaneously? Maybe they didn't appear for a different reason. Maybe you offered a kind of meat that maggots don't like. Maybe it was too hot, or too cold, or too bright, or too dark. Maybe the maggots need air and they couldn't breathe in a sealed container. To really prove that maggots can't appear spontaneously in closed containers, you need to show that maggots don't appear, but you also need to show that they would have appeared, except for the fact that you didn't let flies in. To make a really convincing experiment, you needed to have a second container, similar to your covered container in as many ways as possible, except flies are allowed to enter one and not the other. The second container shows that worms like the home you created for them. The first shows that they can't appear there if you close the door. This was Francesco Redi's contribution to science. This was his own addition to the experimental tradition he inherited from Galileo. Redi designed the experimental control. He placed similar samples of meat in two containers, one open and the other covered with gauze, allowing air to pass through, but not maggots. In the open container, he observed flies coming and going and the eventual appearance of maggots, which then turned into flies. In the covered container, he eventually observed maggots on the outside of the gauze trying to get in, but no maggots on the meat. The open container showed that the conditions were right for maggots, and the closed container showed that they couldn't appear inside if flies can't come in through an opening. With a controlled experiment, Redi had shown convincingly that worms were not generated spontaneously in rotting meat. They came from invisible eggs deposited there by flies. A few of Redi's followers tried similar experiments with different bugs, and they found more insects that reproduce in the same way as flies. The microscopists also discovered some other insects that lay eggs that nobody had noticed before because the eggs were too small to see without the microscope. In his later work on parasites, Redi himself discovered numerous examples of invisible small eggs. Kircher's belief in spontaneous generation had been based on anecdotal observations and vague theorizing. Redi's carefully controlled and documented experiments with the support of similar experiments of others placed him on much more solid ground when he expressed his new belief that, quote, "No animal of any kind is ever bred in dead flesh unless there be a previous egg deposit." Unquote. Redi's research also brought hope. If pests and parasites can appear spontaneously, then there isn't much we can do about them. Redi showed us that they can't just appear anywhere they want to. They follow rules, and if we understand the rules, then we can develop defenses against them. Redi and his contemporaries had discovered many examples of invisible eggs and of the metamorphosis of worms into bugs. They had shown that in many cases where living things seemed to appear from nothing, They actually still come from parents. It's just that there might be some invisible eggs or a weird life form in between. They had shown how insects can reproduce in a repeating cycle, like that of other animals, except maybe a little weirder and more complicated. But had they proven that all life must come from prior life? Even Redi wasn't convinced that it was true as a universal principle. He was unable to find an explanation for the appearance of gallflies and intestinal worms, for example, and he reluctantly allowed that these might somehow be spontaneously generated. Incidentally, one of Redi's younger associates was a doctor by the name of Giovanni Cosimo Bonomo. Most microscopists up until now had either been professional scientists or microscope hobbyists. Bonomo was one of the first professional doctors to try to see if the microscope had any value in the practice of medicine. While studying chronic itch, he applied his microscope to the skin and sheddings of the patients, and he consistently discovered tiny creatures there. Bonomo provided sketches and descriptions of the creatures. They had many legs and, quote, two little horns at the end of a snout, unquote. He also described the creature's eggs and explained the contagious nature of the itch as the passage of the creature from one person to another. Redi's friend Bonomo was the discoverer of the itch mite, now called Scarcoptus scabii. This discovery could be considered the first evidence for a link between a disease and a microscopic cause, more so than Kircher's worms, but it was still hardly conclusive. Bonomo had a big row with the church over it, and the idea that the mite causes the itch was pretty well rejected until the time of Pasteur.